Will the history of astronomy be divided into before Webb and after Webb? I truly believe it will. Something remarkable is unfolding, but we cannot yet determine whether it is an observational error, a misinterpretation, or nature revealing an unexpected phenomenon. Perhaps a new form of dark matter, an unknown type of dark energy, or something even more astonishing. If a Nobel Prize-worthy discovery is hidden within these findings, this could certainly be one of them. Take a look at this image. What you see here is an incredibly distant cosmic structure, glowing intensely in the early universe. The discovery of this luminous object has helped resolve a long-standing mystery in astronomy. According to our current understanding, the universe came into existence about 14 billion years ago. Following the Big Bang, it entered a phase of total darkness, known as the Dark Ages. During this period, the cosmos was filled with dense clouds of gas, making it impossible to observe anything, even with the most advanced telescope ever built. However, for decades, scientists have been detecting strange light emanating from within these dark clouds. A recent groundbreaking discovery has ignited debate among astronomers. For the first time, the Webb telescope has identified two ancient galaxies that appear fundamentally different from those we are familiar with, raising profound questions about their origins. These revelations challenge our current models. Have we miscalculated the universe's age, or have we misunderstood how galaxies formed? What are these strange lights and where do they originate? New findings from the Webb telescope have finally unraveled this mystery, suggesting that our previous assumptions about the early universe may require revision. The latest Webb telescope images reveal that this light is actually a strong source of Lyman alpha emissions. These observations indicate that galactic mergers were far more frequent in the early universe than we had been able to detect before Webb's arrival. These interactions and the resulting bursts of star formation played a crucial role in producing the Lyman alpha emissions. However, scientists had long believed that such emissions should have been blocked by the thick hydrogen clouds filling intergalactic space during the Dark Ages, making them undetectable. Yet we are seeing them. Recently, researchers uncovered that as stellar masses accumulated and stars ignited within these primordial galaxies, two key events occurred. First, these stars emitted Lyman alpha radiation. Second, they created expanding bubbles and pathways of ionized hydrogen within the dense, opaque clouds of neutral hydrogen gas. These ionized regions provided a passageway for the Lyman alpha emissions to escape. This discovery implies that stars could, in fact, illuminate objects beyond the Dark Ages. Even more astonishingly, in another recent deep-field image, scientists detected two galaxies that formed beyond the period of cosmic darkness. These galaxies appear fundamentally different from any previously observed structures. Moreover, they exhibit an extreme redshift, suggesting an enormous distance and significant age. If these objects are indeed galaxies, their existence presents a serious problem for our current understanding of cosmic evolution. This graphical representation offers a comprehensive overview of the most distant galaxies ever identified, thanks to Webb's unparalleled observational capabilities. Among them, one particular galaxy, GNZ11, was initially spotted by the Hubble telescope and is located an astonishing 13.2 billion light-years away. A newly captured image by Webb has revealed something extraordinary about this galaxy. Astronomers have identified a supermassive black hole at its core. This discovery establishes it as the most distant black hole ever detected, forming just 400 million years after the Big Bang. The sheer size of this black hole defies our current understanding of early universe physics. Conventional theories suggest that supermassive black holes form either from the deaths of the first stars or through successive mergers of smaller black holes. However, the timeline does not align. These processes should not have been capable of creating such an enormous black hole so early in cosmic history. This suggests that we may need a completely new approach to understanding the formation of massive black holes in the infant universe. But there is something even more shocking hidden within this data. As seen here, these galaxies represent the most distant structures ever identified by Webb. The red markers indicate galaxies that have already been confirmed through spectroscopic analysis. The farthest confirmed galaxy to date is named GZ130, existing approximately 13.47 billion light-years away. Yet there is an even more astonishing detail. Two of the most distant galaxies ever detected appear at a redshift of around 16, meaning they existed before the end of the Dark Ages. This is highly unexpected because standard cosmological models predict that galaxies could not have formed until after the Dark Ages ended. And yet here we are, observing massive and highly developed galaxies at a time when they should not exist. This discovery forces us to confront a fundamental question. How do we explain the existence of these galaxies? One possibility is that the universe is far older than we have previously believed. Alternatively, something highly unusual may have happened following the Big Bang, an event that drastically accelerated galaxy formation. While spectroscopic observations of these galaxies are still pending, if their predicted redshifts are confirmed, it would completely upend the foundations of cosmology as we know it. Another intriguing hypothesis gaining traction among scientists is the conformal cyclic cosmology, CCC model. This cyclical universe theory, proposed by Nobel laureate Dr. Roger Penrose, suggests that our universe is not the first, but rather one in a series of cosmic epochs. According to Penrose, an earlier universe, what he calls the previous eon, preceded our own, and at its end, black holes gradually evaporated, as predicted by Stephen Hawking. The energy released from this evaporation, in turn, triggered the Big Bang that gave rise to our current universe. Penrose further suggests that remnants of dead black holes from this past universe could explain the unusual rapid expansion of the early cosmos. Scientists now speculate that these ancient black holes may also account for the existence of supermassive black holes and enormous galaxies at a time when they should not have been able to form. Every discovery made by the Webb telescope so far challenges our fundamental understanding of the universe. In just 3 years of operation, Webb has already shattered multiple cosmic records, including identifying the most distant galaxy, the farthest known protocluster of galaxies, the most remote black hole, the oldest red supergiant star, the most distant gravitational lens, and the farthest quasar ever observed. These revelations raise profound possibilities. Could our universe be significantly older than we thought? Might it be part of a vast chain of interconnected universes? Or has it perhaps always existed without a true beginning? Given the seemingly infinite scale of the cosmos, the idea of an infinitely old universe is not as far-fetched as it might seem. What we currently call the Big Bang could simply represent a transitional event in an ongoing, eternal sequence, rather than the absolute beginning of everything. Finally, what do you think about these discoveries? Could our entire understanding of the universe be wrong? Let us know your thoughts in the comments below.